In Visual Basic, the elementary or built-in data types all map to classes in the .NET framework. At the top of the class hierarchy, you find a class called Object, and it's the equivalent of the object data type in Visual Basic. You can take any value in Visual Basic and data type it as an object. Another way of saying it is that you can widen any data type to an object. You can find the documentation for the object data type here, and I'll show you some examples of how the object data type and class behave. I'm working in a project called Object Data Type. It's an empty project that will let me test some code. And I'll add the code here in the Run Code subroutine. I'm going to declare a variable called O and data type it as the object data type. And I'm not initially going to assign it any value. With numeric data types, such as integer, double, and so on, the default value, if you don't assign a value yourself, is 0. But with the object data type, it's something called nothing. Nothing is the equivalent of null in other programming languages. I'm not going to initially assign anything to this variable, I'm just declaring it, and then I'll add some conditional code, and I'll use a function called isNothing, and pass in the variable O. If that condition is true, I'll output a string of no object exists. I'll run the code and click the button, and I see that the condition is true. So the isNothing function is a good way of testing complex object references to see if something has been instantiated. Now I'll change this code and initialize the object with equals new, and then I'll call the object class's constructor method. You can write this code either with or without the parentheses. Then I'll go down to my conditional block, and I'll add an else clause, and then I'll output the following string, before assignment to value, and then I'm going to use an expression that outputs the data type of this variable as a string. It looks like this, o.getType.toString. I'll run that code, click the Go button, and I see that the object data type is currently mapped to a class called System.Object. Now, the nature of this variable, because it's an instance of the object class, is that it can morph at runtime into any other class. It makes it highly dynamic. As I've mentioned previously, this approach won't get you the best performance in most applications, but it will give you a lot of flexibility. So now I'm going to add some code down here. I'll assign the variable O to a value of 1. Then I'll make a copy of this output command, and I'll paste it in here. And I'll change the label to asNumber. Then I'll take these 2 lines of code, and I'll copy and paste them, and I'll change the assignment this time to my name as a string, and then change the label to asString. So the nature of this variable, because I data typed it as an object, is that it can change from one data type to the next. And then in the background, it's going to be assigned to instances of different .NET Framework classes. I'll run the code and test it again, and I see that it starts off as System.Object, then it morphs into a number, an instance of a class called System.int32, and then into a string as System.String. And I could continue with this exercise and show that it can morph into anything. Finally, I'll show an example of taking a value that's an integer and then taking another value that's data typed as an object and assigning them to each other to see what happens. At the end of the existing code, I'll create a new integer variable called src for source, and I'll assign it a value. Then I'll declare a variable named target and type it as an object and assign it to the value of source. Then I'll output a string of target value and append to that the value of the target variable. I'll run the code, and here's the result. The object variable, target, receives the integer value and shows its actual value. And as I showed previously, it will turn into an instance of the appropriate .NET Framework class. The object data type and its underlying capability of morphing into different classes gives you enormous dynamic flexibility in your programming. It does cost you in terms of performance, but when you need flexibility, it can accomplish that.